A while back, I built a Monte Carlo simulation model in Python. I'd now like to share that model with colleagues and have a nice user interface experience for them. So in this video, I'm going to walk you through how I built that interface using my favorite web app software, Streamlit. Let's take a look at the Streamlit interface we're going to build. Underlying this interface is a Monte Carlo simulation model of the multi-period news vendor problem. That's a stochastic problem where we're purchasing newspapers each day, and those newspapers perish at the end of the day. They need to be disposed of, or we need to sell them all. So we're either going to make money or we're going to have to dispose of them and lose some money. In some cases, you can have a salvage value represented here, where we get some of the money back per item not sold. It's a stochastic problem, so we're going to input different types of demand. So the first type of sampling that's going to occur in the model is whether it is a good sales day, a fair sales day, or a poor sales day. Once the day has been sampled, the simulation model will sample the total number of sales on that day, ranging between 40 and 100, and that will follow a discrete distribution. So we can see here, for example, that on a good day, it's most likely that we'll sell between 70 and 80 newspapers, and on a poor day it's most likely that we'll sell only 40 newspapers. If we wanted to change the probability distribution for the likelihood of a good to poor day or the number of sales on a given day, we can easily upload new CSV files containing that information using the browse files option. So here I've got two files, one labeled day types and the other labeled demand probabilities. I want to upload the day types file, so I double click on that. That will appear immediately as a probability profile within your Streamlit app. And we can see here that this scenario focuses exclusively on good sales days. If we wanted to quickly drop back to default settings, we can vary simpler parameters here in the sidebar, where we can change the purchase cost, the sale price, or the salvage price. And we can vary the amount we're ordering using this slider. We can change the planning period for this multi-period news vendor problem here. So we could go as low as 2. It won't let us go as 1 because that's no longer a multi-period problem. And we can go as high as 100. I think we should get an error message if we go over that. And then lastly, we can vary the number of replications we run. So if we wanted a more detailed answer, we wanted to be a little bit more sure about the spread of profit, we could run 10,000 replications or 100,000. We can click on the Run Simulation button and we'll get a progress bar. And then we've got some statistics displayed on our particular configuration, showing the mean daily profit, some descriptive statistics about the distribution of that daily profit, as well as a visual representation of that using a histogram that we've built in Plotly. All of the Streamlit code we're going to write today is available on GitHub. I'll link to that in the description below. The code for the Monte Carlo simulation is stored within a module called newsvendor.py. We've developed that in another video, and I'll link to that in the end cards of this video if you'd like to go back and review how we built the simulation model. Let's briefly review how we can run the simulation model. You'll find a code outline in a file called main.py. So from the news vendor module, we're going to import several classes and functions. The first is a class called experiment that allows us to configure the simulation model. For example, what is the salvage price? What is the profit per unit? A function called multiple replications that's going to allow us to run, for example, 1,000 reps of the model. And we've got a function called create profit histogram, which is going to build that Plotly chart for us, which is nice and handy, and we can plug that straight into our Streamlit app. We've also got some string values which basically link to the CSV files for the type of day and the demand, which are both discrete distributions. You'll find those inside the data folder. There's only one function within main.py, and that, surprise, surprise, is called main. See, this is a nice way to lay out your simulation code so you can then quickly convert it to an app. So we've got variables for the purchase cost, sale price, and so on, an order quantity, number of reps. We're reading in the discrete distribution data from two CSV files. We're creating an instance of the experiment class, and we're passing in the parameters, the order quantity, number of periods, and so on. The multiple replications function requires an instance of experiment and the number of replications that we're going to run. Well, that's handy because we've just created an experiment. We can pass that in, and we've set a variable called number of reps. That returns a data frame called results. From that data frame, we're going to focus on the profit column. We're going to describe that column. In the repository, you'll find a conda virtual environment, environment.yaml, that contains all of the dependencies you need to complete this work. There's some instructions to install that with the repository. The name of the environment is MC app. So once that is installed and activated, you can run the main file by typing python main.py. And we can see what is returned is a printout of the description of the profit column within that results data frame. So let's turn this script into a Streamlit app. The first thing we need to do is import Streamlit as ST. And we will give our app a Streamlit title. To run the app, we just need to type Streamlit run and then the name of the file that contains our app code, which in this case is main.py. So we have our app, doesn't do much at the moment. So let's add some basic functionality to the model. The first thing I'll do is add a run button so that when we click on that, we'll create an instance of a simulation experiment and run multiple replications of it. If we save that file, you'll see that then we've got the rerun button for Streamlit available. If we click on that, we've now got the run simulation button. So we can run the simulation. We'll see that's running in the background with the default parameters. So that's created 1,000 replications of the newsvendor problem in the background. But at the moment, we can't see that. If we look at our code, at the moment, what's happening is there is a print statement that looks at that results data frame for the profit column, describes it, and then for everything but the first row, it converts it to pounds. So a simple way to display this in our app is to get rid of this print statement and instead use Streamlit's data frame function. So now when we click on run simulation, it runs in the background and we get some descriptive statistics about the default experiment that we've run with the Monte Carlo model. Streamlit is very user-friendly and its data frame includes a download button, so we can click on this download as CSV button here and it will download those descriptive statistics for us. But what about if we wanted to access the underlying data frame of the 1,000 replications? Well, that's still there, but we need to include a Streamlit download button ourselves. Just to explain what we've done, we've created a download button. It's going to be labeled download results. Its action is going to be convert the results data frame to a CSV. The file is going to be called newsvendor results.csv. So we have our download button here and we click on that. That immediately downloads that CSV to our machine. Let's also add in a Plotly histogram that's interactive that shows the result of each replication of the model. So we've got that within the skeleton code itself. The first thing we need to do is just notice that the level of indentation is not within the button object. So we just need to fix that. So that's easily done. Select all and tab in. We'll call the create profit histogram method that returns a Plotly histogram figure object. And then rather than show, what we'll do is use Streamlit's built-in Plotly chart method. And here is our interactive histogram, which at the moment is displayed directly below the download results button. At the moment, our parameters for the simulation model are static. We can see here that we've got, for example, the purchase cost hard-coded as 33 pence. In a simulation app, you really want to allow your users to be able to vary those. So we can do that with Streamlit input widgets. I'll do that quite quickly here. If you're interested in a very detailed breakdown of the different type of widgets available and how you create them, you can take a look at my SymPy simulation video where we create a user interface using Streamlit. I'll link that above now. So for purchase cost, sale price and salvage price, I'm going to use the ST number input. That requires you to include a label for the input, a minimum value, its current value, which is 33 pence for the purchase cost, and a step value. So here we can see that we now have an input parameter here for the purchase cost, which is 33, and we can change that value up and down by the value of 1 pence and rerun the simulation model. So I've repeated that process for the sales price, the salvage price, the number of days and the number of replications. For the order quantity, I've used a slider that allows us to dynamically move a line up and down between the values of 50 and 100 in increments of 10. At the moment, our app is organized where everything is on a single screen. What I'm going to do is add in a sidebar and move these parameters of the simulation model to there. So if, for example, we were using this on a phone, we wouldn't need to have everything on the screen in one go. And I'm just going to indent all of the parameters that I would like to include in the sidebar within this with Context Manager. Save that and rerun. So as the sidebar can be optionally hidden from the user, it's quite good practice to at least include a summary of the main configuration of the model on the main page. So I'm going to create 3 columns for that. So we've used st.columns to create 3 column objects called column 1, column 2, and column 3. We're using the context manager for column 1, and we're inserting a metric into there, which I've called cost structure. And that's just showing the purchase cost going to the sale price. So I've added in the salvage value and the order quantity and rerun. We've got our summary of the current configuration. And if we switch over to our sidebar, we can then change the price structure, for example, the sale price and the purchase cost, flick back, and we've updated our current configuration. Now, some of the inputs to the model can't be described as simple numeric inputs. They're actually configuration files that describe a probability distribution. So we've got the type of day and the demand on a type of day within this Monte Carlo simulation model. So the first thing we'll do is add in an expander context manager. And within that, we'll have a Streamlit tab object that will allow us to tab between the day type data frame and the data frame for the quantity of sales on a given day. So we've created a tab here for the type of day and the sales. You can see that we've passed those in as a list of strings here into the st.tabs function. And then we've opened tab 1, and in there I've created a data frame for our day type pandas data frame we've included in the app. And I've just done a bit of Streamlit magic here where I've configured the columns to display in a certain way. Here they're displaying the probability column as a progress column with a new label called probability and a min value and a max value. And we're going to hide the index of the data frame as that's of no value. So if we save that, this is what it looks like. So we've got our day type and our probability. Now, because this information is being displayed in an app, I think it needs better formatting than we've included for the day type column. So what I'd like to do is modify the name of the column and also modify these good, fair, and poor labels within the rows so that they're properly capitalized and they include an emoji. Now, I couldn't find a straightforward way to do that with Streamlit itself. So instead, I've included a module called app utility. And in there, we've got a function called fetch day type, which accepts a string or value for the path to the CSV file. What that does is it reads in the CSV file, but it also replaces the values within the day type column by using a dictionary where it maps good, for example, to a sun emoji and good. And then I've used the rename method of the data frame and passed in a dictionary. We should remember that we're then passing that data frame to an experiment that's going to be run within a Monte Carlo simulation, and it expects it within a certain format. In particular, it expects it to have the day type column header, and it also expects these labels that are standard. So I also needed to include a function called remove day type formatting, where we pass in the data frame, and it effectively does the reverse operation and strips away that additional formatting we've put in and replaces it with the original. So now you can see that we've got our renamed column and the emojis included, and we can run our simulation model and still obtain results. And we'll repeat that process for the sales configuration file. And again, I've got two matching functions for fetching the data frame and for removing the formatting before we pass that to the experiment. So there we go. For a moment, I forgot to include my fetch demand function, but now you can see that we've got our demand column and for the type of day, as well as all of those being formatted as probability columns. So now the next job is to allow the user to vary that data by uploading their own CSV. So the first thing we'll do is cut and paste that demand configuration inside the expander, just so it's a bit closer. We'll set these equal to none to start off with. And we'll make use of Streamlit's file uploader command here. So it's going to upload a file, and then we need to convert that file to a pandas data frame using the read CSV functionality of pandas. Now, the way Streamlit works is it will read from the top of the file all the way down each time you change a setting within the browser. So if you've not uploaded a file, then uploaded day type will equal none. If it's a null value, then what we need to do is fetch that day type configuration file from the data directory. If not, then we're going to convert this uploaded file into a pandas data frame. So you can see here we've now got an upload file option. So I can click on browse and I can select a scenario file I'd like to upload. So if I choose the day types, for example, you can see we've now got a scenario uploaded to Streamlit, which exclusively focuses on used. Now I can click on the X and revert back to default if I need to. Users can easily get hold of a template file to modify the discrete distribution by clicking on the download button and saving the data as a CSV, like I'm doing here. Then just open that in your favorite spreadsheet program and modify the probabilities as you see fit. So I've used the set page config method within the main function, and I'm passing in a name for the app, a page icon, and importantly, I'm setting the layout to wide. So if we save that and rerun our app and expand, We can now see that our controls are expanding to fill the page. And we can see clearly that this is now too much for one of these controls on its own. So instead, what we'll do is we'll put those into 2 columns. Now, lastly, it would be useful to have a bit of feedback to the user as we run the simulation model that the model is actually running. At the moment, for example, if we choose 10,000 replications and click on run, we can see this little icon at the top of the screen, but ideally we'd have a percentage tracker that showed how much progress had been made in those 10,000 replications. One difficulty with our design is that the actual simulation is occurring in code written in a different module under a function called multiple replications. Luckily, I've set this up in a way so that we can pass a third variable called progress callback that's going to allow us to update a Streamlit progress tracker here. We can take a quick look at the multiple replications function itself. We can see that it's effectively a big for loop that's calculating statistics of a single run of the model and storing that in a Python list. And then each time a replication completes, it checks to see if a progress callback function has been passed in. If it has, it calculates the percentage of the n number of replications complete, and it calls the progress callback function, returning that percentage. So let's add a progress tracker to our app. So here we've got some text that's going to be shown to the user as the model's running, and we've created an instance of a Streamlit progress bar that's going to start from 0 and display that progress text. But we just now need a callback function which is going to vary the percentage complete. So I'm going to create a local function called update progress. That accepts the percentage of replications that are complete. Inside the function, we're going to make use of both the progress text and the progress bar. In fact, what we're going to do is update the progress bar progress complete. So that's pretty simple. I've set the amount of progress complete to an integer of the percentage that's been returned. And I'll also add some text that's displayed to the user. So that's our callback function. Our next job is just to pass that function to the multiple replications function. And after the results are returned, we just want to empty that progress bar again by calling the empty method. We run and click on run. We now have a progress bar charting the number of, in this case, I think 10,000 replications that we are running. And then just to finalize things, I've created a pages directory and added in a license page. That's just loading the license file and showing that to users. In this case, it's an MIT license, and an about page, and that's linking to a YouTube video that I created where we actually code the Monte Carlo simulation model underneath this. I've renamed the main file to simulation model. So now if we want to run that, we type simulation model.py, and now we've got 3 pages in our app. We've got the interactive simulation model where we can run our model nice and quickly and get some results and charts out. We have a license file, and we have an about page with a video that we can watch if we want. What Streamlit projects would you like me to cover next? Would you like me to look at more simulation? Would you like me to look at different types of simulation? Let me know in the comments below, and I'll see you next time.